in this video, I'll be teaching you guys how to solve for radius of convergence for any power series. Now, this video is going to be quite long because the steps for solving radius of convergence are quite tedious. You have to use ratio tests and you have to use multiple other tests as well. But I guarantee you, if you stick with this, you're going to be able to solve a vast majority of radius of convergence problems. So first things first, what is a power series? Okay, so what is a power series? Well, in the traditional series that you've been learning, maybe you would have something that looks like this, 1 over n. All right, but a power series is formatted like so. And the primary difference between a power series and the normal series you've been using is that you have the variable x inside of it now. So instead of just n, you have some variable x. So a power series could look like this, x over n. Right? You have two variables now. N is the variable that your sum is increasing, and x is simply just the variable that's there. So a power series can actually represent a function. So now that you have x, right, now you're just not just adding constants, you're adding x values. It can actually represent a function on a graph, right? So you can actually add up all those values to represent the function on a graph, but that's not too relevant. Let's go ahead and talk about a of n right now. So a of n could be anything. 1 over n. It could be a constant 3. It could be n over n plus 2, n over n squared plus 1, right? Really anything. So let's go ahead and look at the case where a of n is equal to 1 over n. If a of n is equal to 1 over n, you have a series starting at 0. Usually power series will start at 0. That's the typical convention. And you have 1 over n times x minus c to the power of n. So x minus c to the power of n over n is what would happen if your a of n was equal to 1 over n. Right? This could be an example of a power series. All right. Now, here's the thing about c. C is equal to the center of your power series, where your power series is centered at, more specifically. So if I were to, let's say that c is equal to 2 in this case, you have x minus 2, then your power series is centered at 2. If you had positive 2, x plus 2, then your power series would be centered at negative 2. All right. Now, the thing about finding where your power series is centered at is quite important. Now, the reason why this is important is because when you're finding radius of convergence and such like that, there's going to be certain cases where your center is the only answer. Right? So let's go ahead and show you how to find the center. Basically, you just look at whatever's inside the parentheses, set it equal to 0, and then isolate x. So if you isolate x here, you bring the 2 onto the other side, you just get x equal to 2. All right, what if your series looked like this? Right, 3x plus 2, let's say. Well, we have 3x plus 2. Just set it equal to 0. And then isolate for x. So you have put negative 2 on both sides, right? And you divide by 3 on both sides to get x is equal to negative 2 over 3. Therefore, in the case of 3x plus 2, your power series is centered at negative 2 over 3. Just simply requires a little bit of algebraic work to determine where your power series is centered at. Well, now that we got past all the background information stuff, let's talk about the big guns. Let's talk about what the radius and interval of convergence are, okay? So interval and radius of convergence. Let's show what you guys are actually solving for of convergence. So in a power series, there's now the variable x, correct? So let's go ahead and simplify this power series actually. There's now the variable x. So use x minus 2. Well, what if we pick for the value x, let's say x is equal to 2, okay? So your series would look like this. If you pick x is equal to 2 in this case, you have 2 minus 2, which is just 0 to the power of n over n. All right? And all this just equals 0, correct? Well, the series with only zeros will converge to 0, correct? Well, that means for this series right here, if you pick a value of 2 for x, your series will converge. But what happens if we pick a value of, let's say, 3? Let's go ahead and pick 3 here. Well, n is equal to 0. If we rewrite this, we have 3 minus 2, which is simply 1 to the power of n over n. 1 to the power of n is just 1, right? No matter what 1 is to the power of, it's just 1 times 1 times 1 times 1 times 1. Right? 1 will always be 1 to the power of anything will always be 1. Well, now if we pick x is equal to 3 in this case, your series diverges now. This is the harmonic series, right? So there's going to be some interval, some some range of values of x that you can pick to where your series will converge, right? So you're going to pick some values of x to make it so your series converge. And this is what the interval of convergence is. It's the interval of values of x that your series converges, in which your series converges. Okay. So in this case, we picked 2, right, for x. Well, we already determined that x is equal to 2 gives you convergence, right? You would just have 0. And we determined that x is equal to 3 gives you divergence. Now here's the thing, 2 isn't the only value that causes the series to converge. And also, 3 isn't the only value that causes this series to diverge. So we can actually use the ratio test to determine whether or not, so the limit as n approaches infinity, so the ratio test to determine whether or not your series converges or diverges, and you can actually find that interval using the ratio test. And I'll cover all the possible situations in this video, of course. So if we take the absolute value of a of n plus 1 over a of n, we take the limit, we will get some function at the end of it. Okay. Now I'll cover all the values. You could get 0, you get infinity, you could also get absolute value of x minus c times r or something like that. All right. And all these possible situations will give you different answers. But let's first talk about what the interval of convergence or radius of convergence actually is. Let's get the wording down first before I don't want to use a word that you guys don't know. All right. So the interval of convergence could be an example that looks like this: 0 and 2. Okay. So that means any value between 0 and 2 for x. This is for x. Any value between 0 and 2 for x allows this imaginary series, not these guys right here, let's ignore this, this new series, okay, that we haven't written down, any value between 0 and 2 for x will cause your series to converge. Any value outside of that bounds will cause your series to diverge. All right, and the reason why I put open and closed brackets is because I need to differentiate this. Okay, so let's go ahead and tell you what open and closed brackets means. Let's say this is 0 and let's say this is 2. Well, an open bracket just means that you disinclude that number exactly at 0. Any number past 0 is fine, like 0.000001. But when you get to 0, well, that's disincluded. And a closed bracket, right, this closed bracket here, just simply means that you include the value 2 into your interval of convergence. Okay, so this is what we call the interval of convergence. Let's actually leave that number line there. That's quite helpful. This is what we call the interval of convergence, right? It's just the interval of numbers in interval notation for which your values of x causes your series to converge. Now, what's the radius of convergence? Well, the radius of convergence is just your upper value minus your lower bound over 2. Okay, and just take the absolute value to get, well, this is 2 minus 0, which is 2 over 2, which is just 1. So your radius of convergence is just 1, right? If you want to think of it in a different way, the number at the center of 0 and 2 is just simply 1, and the distance between 0 and 2 from the center number is just 1 minus and 1 plus, correct? So this is just 2 and this is just 0. So your radius of convergence is just the distance between the center number of your interval between the end bounds of your interval. Okay, you can actually calculate that by just using this absolute value formula, like upper bound minus lower bound over 2. So now let's cover what you can actually do to find your interval and radius of convergence. So remember what I said about ratio test, correct? The limit as n approaches infinity for a of n plus 1 over a of n. And this can give you multiple different results. All right, go ahead and copy and paste this to represent the results. I need to move this before. So if you get, let's say, if you get 0, right, for the result of your limit as n approaches infinity when you take this ratio test. And a of n is just your sequence inside of your series. Okay. So if you get 0, your radius of convergence is equal to infinity. Therefore, your interval of convergence would simply just be negative infinity to positive infinity. Okay. And if you get this, that means for any value of x, so this is your bounds for x, for any value of x, your series will converge. Okay, an example of this would be, let's say, x to the power of n over n factorial. All right. This is an example of a power series where any value of x will converge, right? No matter what x is, your factorial will completely overpower this exponential when you're going up into infinity. So that means no matter what value x is, well, your factorial will just mess up this exponential. It does nothing. So in this case, no matter what x is, this series will converge. And this would be an example where your ratio test would give you a result 0. Well, what about if your ratio test gives you a result of infinity? That's also possible, right? Well, that just simply means that your radius of convergence is 0. That means x can only equal one value, and that value is just where your power series is centered at. Right? Remember what I said about finding c? You just isolate x. Okay, so let's say you had 5x plus 2. Okay, over n, and this was your series, right? In order to find the center, you simply just need to saying this is not equal to this. I'm not saying this is equal. In order to find the center, you just need to look at whatever inside the parentheses, 5 plus x2, and set it equal to 0. And if you do this, do a little bit of algebra, and you can isolate x. Therefore, the center of this series is negative 2 over 5. So that's how you find the center. So when your radius of convergence is, when your result for the ratio test is infinity, your radius of convergence is 0. That just means that you only have one single point where your, one single value of x where your series will converge. Okay, what if you get something else? Well, you can get something else that looks like the format, this. 1 over r, the absolute value of x minus c. Now, if you get something that looks like this, and trust me, I'm just going to spew a bunch of nonsense right now because you haven't done any problems likely on radius of convergence. So you're really going to learn this when I'm doing the practice problems. You're going to learn this way more. Oh my god. I just breathed in saliva, sorry. But if you can get some format of something that looks like this, okay? And if you get something where you get the absolute value of x minus c, this could also be x minus c squared, that's also possible. If you get the value of x minus c with some coefficient in the front, like 1 over r, okay, you want to set this to be 1 over r to be less than 1. All right. If you set this less than 1, you'll be able to find your interval of convergence, right? So let's go ahead and make a little more space. Let's go ahead and erase this. So whatever answer you get, right, it's going to look like maybe something around this format. Well, you could multiply r onto both sides so that you get the absolute value of x minus c, right? If you multiply r on both sides, all right, r minus r times 1 is just simply r. And r is your radius of convergence in this case, okay? So you can find your radius of convergence like this as well. And what you can actually do is, remember, this is an absolute value. You can actually remove the absolute value so that you get negative r is less than x minus c is greater than r. And if you add c onto every term here, you would be able to get your interval of convergence. You would just simply isolate x. All right? These c's would cancel out, so that you would get, let's erase these. You just need to memorize those. And if you add c onto everything, you should get negative r plus c is less than x is less than r plus c. Now the thing about this is that you could rewrite it so that you get negative r plus c, comma, r plus c. And this right here would be your interval of convergence. Now keep in mind, remember what I said about your closed bracket and open bracket? You would need to test the values at the end of your interval for x in order to determine if your power series converges or diverges. So that's actually one of the most tedious parts when you get an answer that looks like this. And a couple more things that I would like to add to clarify more points is that whatever r value you find, like right here, r, right? It could just be any constant. Any constant. Most of the time, it's just going to be some constant, maybe 1 over 2, maybe 2, maybe 3, right? Any real number, okay? And also another thing is that in power series, it always converges. It will always have some radius of convergence, all right? So don't think that there's going to be some answer like no radius of convergence, okay? It will always have some radius of convergence. And even if it only has one point in which it converges, that's simply when, well, your limit is equal to infinity, right? So now, knowing this, let's go ahead and do some problems to actually apply what we learned. First things first, let's go ahead and find the radius convergence for this problem here. First things, we need to find the limit as n approaching infinity for a of n plus 1 over a of n, right? So a of n plus 1 is just, so let's keep in mind that this right here is a of n. A of n plus 1 is xn plus 1 over n plus 1 factorial times, technically divided by, right, since it's the a of n plus 1 over a of n, we are dividing by a of n. So a of n is just simply x of n over n factorial, right? This is our original a of n function. Well, the thing that we can do with this is, remember, if you divide by some fraction, you could just multiply by the reciprocal. So let's go ahead and flip this fraction around so that we multiply by n factorial over x to the power of n. And we can actually simplify this limit so that we get x of n times x to the power of 1. Remember, you could separate exponentials. When you multiply exponentials with the same base, you simply add their exponents. Okay. And we can also separate this factorial to get n plus 1 times n factorial over x of n. Well, these cancel out. So we just simply get left off with the limit as n approaches infinity for the absolute value of x over n plus 1. Well, if we take the limit as n approaches infinity for x over, technically 1 over n plus 1 times absolute value of x, right? We could just separate the absolute values like this. We just get 1 over infinity times the absolute value of x. Well, 1 over infinity is just 0, so your answer for this problem is just 0. And remember what we said, if the answer for your limit is equal to 0, if the answer for your limit after the ratio test is equal to 0, then your radius of convergence is equal to infinity. Therefore, your interval of convergence, the values in which x causes your power series to converge, is just negative infinity to positive infinity. So any real number for x will allow this power series to converge. So we have the series n factorial x to the power of n. Now, some of you may already notice that this series probably diverges unless x is equal to 0, right? Since this function is just constantly increasing, right, and is, well, when you take a sum, n from 0 to infinity, right, just constantly increases n, so the values of the series will constantly increase. You can already tell this guy will diverge unless x is equal to 0. But let's go ahead and actually test this out. Right. Limit as n approaches infinity for the absolute value of n plus 1 factorial times x to the power of n plus 1 over n factorial times x of n. Alright, we're going to actually separate this limit to make it simpler to solve to get n plus 1 n factorial times x of n times x over n factorial x to the power of n. Okay, let's go ahead and separate this. Alright, you actually simplify this to get your limit as n approaches infinity for the absolute value of n plus 1 times x. Now, if you just plug in for the limit, if you just simply plug in, you would get infinity plus 1 times x. Well, infinity plus 1 is just infinity, and infinity times x is just infinity. So remember, if your value for the limit is equal to infinity, then your radius of convergence is equal to 0. Therefore, remember, your value, why do I keep writing 3? The value that your series will converge at is whatever value your x is centered at. Okay? And where's x centered here? Well, since you have nothing like this format here, C, in this case, your center is just equal to 0. All right, this right here are the same thing, but if you just set C to equal to 0, you get x to the power of n, right? If you set C equals 0 here, it just cancels out, you get x to the power of n. So that means the center of this power series is just equal to 0. So since C is equal to 0, the only value that your series will converge at, that your power series will converge at, is when x is equal to 0. And when x is equal to 0, well, this will be your series, right? When x equals 0, you'll have n factorial times n to the power times 0 to the power of n, which is just 0, right? And of course, if you sum a bunch of zeros, well, they'll just keep equaling 0. So that is where this series will converge at. Now, let's consider this series right here. Remember, we need to take the limit as n approaches infinity for a of n plus 1, which is n plus 1 squared times xn plus 1 over 3n plus 1 divided by a of n, which is n squared times x of n over 3n. Now remember, we could simply just multiply by the reciprocal of this fraction, so we can actually flip over this fraction to get times 3n over n squared times x to the power of n. All right, well, now that we have this limit, let's go ahead and simplify it. So the limit as n approaches infinity for n plus 1 squared times x of n times x to the power of 1 over 3n times 3 to the power of 1 times 3 to the power of n over n squared times x to the n. And we can cancel out a bunch of things. These cancel, this cancels, this cancels. Once you get everything canceled that you possibly can, you should get the limit as n plus 1 squared times x over 3n squared. Well, we can separate this limit again. We can separate the n terms and the x terms to get this. And remember, if you plug in infinity, right? Not plug in for infinity. If you take a limit as n approaches infinity for anything, well, you only care about the largest exponential values, right? So if you expand n plus 1 squared, you should get n squared plus 2n plus 1. And the largest exponent value is n squared. So we only care about the n squared in this numerator here. So we should rewrite the limit as absolute value of n squared over 3n squared times the absolute value of x. Okay. Well, once you have this, you realize that the n squareds actually cancel. And you get left off with 1 over 3 times the absolute value of x. Now remember the format 1 over r, x minus c, right? Well, if you get this format, you simply need to set this less than 1. And once you set it less than 1, well, there you go. You will have your interval of convergence. Now we just need to evaluate a couple more things to get the interval of convergence in this case. So 1/3 multiplied into this guy will give us the absolute value of x times 3, right? If we multiply 3 on both sides of this equation, this inequality, then we just get the absolute value of x is less than 3. And absolute value of x can be separated to get -3 is less than x, and 3 is greater than x. So this right here will be our interval of convergence. Now here's the thing. We need to test the end values of this new interval. All right. So this is our new interval. We need to test whether or not -3 will give us a converging or diverging series. So let's go ahead and plug in -3 and 3 into this. So let's go ahead and test this out separately. N is equal to 0. N squared times, let's go ahead and -3n over 3 to the power of n. Once we have this, we can simply separate. We can separate n to the power of 2 times -1 to the power of n times 3 to the power of n, right? Over 3 to the power of n and these cancel. So the series that we get that is left over is just n squared times -1 to the power of n. Well, now we simply have an alternating series. Let's go ahead and use the alternating series test. All right, let's go ahead and take the absolute value of this. So the absolute value of a of n in this case is equal to b of n, which is just equal to, we just remove the alternating part to get n squared. Well, here's the thing, b of n is not decreasing. X. And the limit as n approaches infinity for b of n also does not equal 0. So this alternating series test fails. All right. Therefore, this alternating series here diverges. So we actually disinclude the point 3, -3 for our interval. Okay. So we use an open bracket here. Now let's go ahead and test out 3. All right. So we rewrite the series, n is equal to 0. And now we set x equal to 3. So we get 3 squared over, no, not 3 squared, 3 to the power of n over 3 to the power of n. These terms actually cancel out. And we just get n squared. Well, this clearly diverges, all right? All the values just keep increasing. If we use divergence test, you know what, let's just use divergence test for to prove this. Take the limit as n approaches infinity for a of n, or for n squared, we get infinity, right? This doesn't equal 0, therefore the series diverges, okay? So when x is equal to 3, the series also diverges, so we should use an open bracket here, an open parentheses. Therefore, our interval of convergence is 3, and remember, we subtract upper bound from lower bound and divide it by 2. And you should get 3 minus -3, which is 6 over 2, which is equal to 3. Therefore, this right here is our radius of convergence, and this right here is our interval of convergence. Let's go ahead and solve this. First, we use the ratio test. Remember, the limit as n approaches infinity for a of n plus 1. So we get n plus 1 here over a of over n plus 1 squared times the reciprocal of a of n, which is n squared over 3x minus 2 to the power of n. Well, we can simplify this limit to get n approaching infinity for 3 of x minus 2 to the power of n times 3 of x minus 2 over n plus 1 squared times n squared over 3x minus 2 n. Oh no. I wrote n here. I mean, I wrote 2 here. Yeah, because it's supposed to be n. Okay. Well, once we have this, we can cancel out some values to get a new limit n approaching infinity for 3x minus 2 for n squared over n plus 1 squared. And remember, when you take a limit to infinity, you only care about the largest exponential values in the numerator and the denominator. So we just get n squared over n squared times 3x minus 2. Okay, well, once we have this, we simply need to take this limit. We realize that these actually cancel out, so we get just the absolute value of 3x minus 2. Well, this right here is the format what we talked about before, right? So all we need to do is set this less than 1. So 3x minus 2 less than 1 gives us this. If we separate the absolute value to get -1 minus 2 less than 1, we get this. Okay. If we add 2 onto each term as inequality, we get 1 is less than 3x is less than 3. If we divide by 3 on each term, you should get 1 over 3 is less than x less than 1. So this right here is our interval of convergence. But remember, we need to test the end values of your interval. So 1 over 3 and 1. Okay. So let's rewrite the series to get 1 over 3. So we put 1 over 3 here. We should get 3 times 1 over 3, which is simply 1 minus 2 n over n squared, which is equal to negative 1 to the power of n over n squared. Well, if we use the alternating series test, let's go ahead and take the absolute value of a of n to get b of n, and b of n in this case this includes the alternating part of the series to get 1 over n squared. Well, we already know 1 over n squared converges, right? That's the p series test. Let's go ahead and use the alternating series test conditions. So b of n is decreasing, right? As n increases, the sequence decreases. Okay. And let's go ahead and take the limit as n approaches infinity for 1 over n squared. And this does equal 0. Therefore, according to the alternating series test, this series converges. All right. Therefore, 1 over 3 is in closed brackets for our interval. Okay. How about 1? So if we test 1, we should get 3 minus 2 to the power of n over n squared. If we rewrite this series, we should get 1 to the power of n over n squared. And 1 to the power of n is just 1, right? So we get n squared. Well, this is a simple plain old p series test. P is greater than 1, therefore this series converges as well. So the value, when x is equal to 1, your series also does converge. Therefore, in, again, closed brackets, this will be your interval of convergence. Now let's go ahead and find the radius of convergence. 1 minus 1 over 3 over 2, simply 2 over 3 over 2, right? 2 over 3 over 2 is just equal to 1 over 3. Therefore, this right here is equal to your radius of convergence. 1 over 3 is your radius of convergence. 1 over 3 to 1 in closed brackets is your interval of convergence. All right, last problem. Let's go ahead and take the limit as n approaches infinity for a of n plus 1, which is just n plus 1 factorial times x minus 3n plus 1 over a of n. So it's n factorial times x minus 3 to the power of n. All right, simplify this limit. So if we simplify the limit, we should get n plus 1 times n factorial times x minus 3 to the power of n times x minus 3 over n factorial times x minus 3 to the power of n. Okay, these values cancel out. So we just simply get left off with the limit as n approaches infinity for n plus 1 and x minus 3. Well, if we simply plug in infinity here, we should get that infinity plus 1 times x minus 3. Well, here's the thing about this limit. This just equals infinity. Okay. So remember, when the answer for your limit is equal to infinity, your radius of convergence is equal to 0. And the x value in which you converge at is just equal to, I keep writing 3 instead of c. Well, I guess in this case, 3 is the centered value. But we have your centered as your value in which x converges. Okay? So let's go ahead and look at this function. We have the format x minus 3, remember? And we just simply need to set this equal to 0. We need to isolate x, and then we should get that x is equal to 3. Okay, and 3 is your centered value of your series, power series. So that means that the only value in which your series converges is when x is equal to 3. And that makes sense, right? If you plug in for 3 here, you get 3 minus 3, which is equal to 0 to the power of n. 0 to the power of n, just 0. 0 times everything else is just equal to 0. So everything just zeroes out, and then now your series converges at 0. Okay, so I know, long video, but if you stuck with it until this end, congratulations. You are now a master at finding the radius of convergence. So, as always, if you have any questions, put it down in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thanks for watching.